Okay, so let me welcome every one of us to how to use epanet to model a water reticulation system. So what I'll first of all do is to model this layout. I'll model this layout, then I will now show us how to impute the values, the variables. Remember what I said, you need 4 variables to design or model your water reticulation system. You need 2 variables for the pipes, 2 variables for the nodes or the junctions. For the pipes, you need the length of the pipe and the diameter of the pipe. For the nodes, you need the elevation and the water demand at that node point. And I also took us to how the calculation sheet looks like. This is your calculation sheet. So here you put the length of the pipe, the discharge in liter per second, the diameter, and the elevations. So with these 4 parameters, you go to the epanet and then model that system. So I also said we should open one of our materials in our called epanet exercise 1. So it's a simple tutorial that will help us have a mastery of how this epanet works. So if you look at this, this is now the network we're going to draw, right? After drawing this network, it's expected that you must have designed those 4 parameters, which are here. For the node parameters, you will get the elevation and the demand, elevation and the demand, elevation and the demand for every node. So there are about 8 nodes here. So I'll get the elevation and the demand in each of these nodes. So this demand here is now the water that will take care of the riparian houses connected to these service points. That's what it means. Then further, you also have to get the remaining 2 parameters for the pipe. And those are the pipe parameters, right? Which is the length of each pipe and the diameter of each pipe. So each pipe we must have a length and it must have diameter. So with those 4, you move to your epanet software and model your epanet software. So for instance, this exercise we are doing, which is this model, assuming I'm asked to model this, for instance, stay with me, let me show you how to import it into epanet, which is the first thing you need to do. So the first thing I'll do is I'll need to import this as a background on epanet. So how do I import it? All of us know the tool called take a snapshot or something like that in Adobe. So I need to convert it to JPEG. So here I will come here. No, this is not too good. I will come here and I will, yeah. This is copy. I'll copy it. I'll go to my computer, search, I'll type Paint. There's a software called Paint that looks like CorelDRAW. I will use it to convert this JPEG. I use to convert this Adobe into JPEG. I also Control V or Control Paste, right? I'll crop it. So this is now in JPEG. I will save it. The epanet accepts only file in JPEG format. So I'll say save as. I will save it as, let me call it day 3. Day 3 design, right? I'll make sure I save it in the folder where my work is. Very, very important. You must know where you are saving it. You must save it where you can find it, because on the long run, you will need it. So I'll come here and I'll call it day 3 design. I'll say save. Remember, here is in JPEG, or you can put it in bitmap. In JPEG or in bitmap. in JPEG or bitmap, I'll say save. I'll say yes. I've saved this. Now I'll go and open my epanet. I can close this one. I can close all this. I'll go and open my epanet file. This is my epanet. In epanet, I'll go to project. I'll go to view rather. When I get to view, I'll go to backdrop. I'll say load. I'll go and look for where I saved it. Right? That's why it's good to you to have this discipline of saving your files in the appropriate folder, so you don't go looking for it. We'll do one. Day 3 design. I'll click on it. I'll say open. Now that file is now inside my epanet to provide me with a guide. Why is it here? It's here to provide me with a guide. It's like a background because I'm going to digitize. I'm going to, the word is digitization. Some will call it, yeah, that's the word. I'm going to digitize it. So in this epanet software, these are what we call the toolbars. If you want to know what any of them does, just hover around it. Just place your mouse around it to tell you what it does. So this one is to add label. This one is a valve. This one is a pump. This one is a pipe. This one is a tank. This one is a reservoir. This is a junction or node. Remember, we discussed this last week. This is to zoom, full extent. Zoom out, zoom in, pan, select region, select object. This select object is important. Every time one command is on board, it's on. For you to stop that command, you need to go and click this black arrow so that it will deselect every previous. If you click on cell or something, it will keep repeating that until you go and click this select. Then most of what you have here are already in the menu. For instance, this one is new, this one is open, this one is save, this one is to print, this one is to copy, this one is to delete, this one is to search, find, this one is to run your model, this one is to query your model, this one is to graph, to produce graph, this one is to produce table reports, this one is to provide you with options. Most of these things, if you go here into view, you see all of them. If you go into edit, you see copy, select, region. If you go to file, the usual culprits are there. If you go to project, you see default, you see run analysis, you see analysis option, onto report. Because of not doing design, to not give us, most of them are not active until you've done something. So now what do I do next? I will now come here and pick this add junction. If I pick add junction, I will now start to add here, here, here. Now, if it looks tiny, I don't like it, I can go to view, I'll go to options, I will increase it to size 6. If I want the link to be much, I'll increase to 2. You can change a lot here. So you can see it's now bigger. I'll go back and pick, I'll add one here, I'll add one at the ends. I'll go and click this black arrow to drop it. Here, I will need a tank because this is the highest point. So it's supplying water. So I'll click on this. Either I click on tank or I click on reservoir, but let me just click tank. The next thing, I'll go and click this black arrow. I'll connect them with pipes. I'll click on this pipe. I'll click here. Just stay with me. I'll correct those lines later. Vertex. So If I click on this center, it will turn into a pencil. Until I click next center, it will exit, meaning that it has drawn a pipe section. If you look here, it's telling me the number of pipes I have drawn. Pipe 1, pipe 2, pipe 3, pipe 7. So I'm on pipe 7 now. So here, this thing is not following the street well. So I'll go and click this black arrow. I'll click on what we call vertex, this one, vertex. If I click on vertex, I'll come here, I'll click on this pipe, I'll right click, I'll say add vertex. I'll right click and say add vertex. The first time it will just as if nothing happened. The second time, it will add a node. So if I now click on this node, click down and drag. I'll click on this node and drag. Next, I'll click on this one. I'll add vertex. First time, it will be as if nothing happened. Second time, you see a node there. I'm thinking I should give us some time to try our hands on it. I know some people will say, just go on, we'll watch the video, we'll do it. I hope and I pray you do it, because this is a wonderful software. You can use and do a whole lot. Did you see it? Of course, some of you know what I'm trying to achieve. You see, this one I click, it didn't touch, so I'll delete it. It must be if I click, and I click this one, it will go off to give me that pipe section. I'll go here, drop it, and pick vertex. Let me add 3. So I can use it to draw a perfect curvature. Somebody say, can we draw in color? No, you don't need to draw in color. It's the same network. Until you run your model, the epanet will color code it based on the parameters of the pipe. I will come to that. Are you following? Or is someone lost? So let me stop here. I don't need to make it look perfect, but at least we understand the whole thing. Now, this is not a complete network, right? Let me show you what a complete network should look like. A complete network should look like, I will pick here and drop reservoir here, and then connect this reservoir with the pump. This is what the complete network should look like. This is what the complete network should look like, right? So that this is my water source, and this is my pump. So I'll pump water from the water source to the upper reservoir, or this could also be my treatment plant, right? Maybe the source is somewhere here. Then from source to water treatment plant using some pump, inverted switch pump. Then from here, I pump it through water pump to the upper reservoir. the reservoir is distributed into the community. Any question? Okay, somebody say, will this pipeline be drawn to scale? There is a provision to draw it to scale. I'll teach you that. I will send you the video how to do that, because that will take me another 30 minutes to do, which we don't have that time. So after this class, I'm going to send you a video, even on the platform, how you can scale, such a way that when you scale, as you are drawing this pipe, it's automatically capturing the original length of the pipe. Yes, there's a place you can do that. And it's also explained in the manual. Meanwhile, I've also shared the manual. The manual is there. The manual for this, 200 pages. So it's also, in fact, it's from the manual that I called out this exercise. So this is what the typical normal wastewater, drinking water network should look like. It must have water source and ground pump, ground reservoir, or water treatment plant, from where you pump clean water to the upper reservoir. From the upper reservoir, the water is distributed by gravity. So to just show you the beauty of what I've done, I can go back to view. Under backdrop, I'll say unload. Remember, the first time was load, unload. It will give me a network like this. And remember, I told you this one does not follow anywhere. So you can see this network now. I relate it to this one. So you could see a resemblance, right? So this is how you do. So with this now, I want you to assume that this is now this. Let me assume that you've done all what we did and you came up with this. So I'm going to show you how to draw this now. I'm going to draw this again so that will help you. I'm going to draw this again, right? But I want you to understand that where this thing was drawn, it might look arbitrary, but it's not arbitrary. It must follow the layout. It's following the layout. It's following layout. Question, please, sorry. No question, we continue. So, should I give us 5 minutes to open the software? So now, if you have opened the software, if you have downloaded the software, can you say done on the chat box? Just type done. Let me see the number of persons that have done that. The main use for the vertex is to draw curvature, curve lines. Okay, Joseph Duncan says done. Means he has opened, he has downloaded the software, he has opened it. So please, sir, keep it open, keep the software open, keep the interface open, so we can draw this together. Who again has downloaded the software? Okay, you can pump up. Please, who is Galaxy A20? Can you edit it and write your real name? Galaxy A20, just click on the name. And please, okay. We send the exercise link. I didn't even send it a link, sir. I uploaded it on the chat box. It's on the chat box. It's on the chat box. Okay, because this thing is being recorded, let me continue, and we have only 2 hours. Let me continue. I will send us the video, then we can now play with the video, we can now learn more. Now, ideally, I'm supposed to ask us to print out this tutorial and hold it in your hands. Now, let me finish this. So from here now, what do we do? I will now come here, I'll double click on this junction. It will open the property bar for me.
Don't watch that thing.
So when it opens like this, I will come here. The elevation, if you remember the elevation of point 13, somewhere here, it's about 252. Remember how we did yesterday, 252. So I'll now come here, I'll double click and say 252. Then what's the base demand? The base demand there was 0.58, remember? That is it. So I have imputed the value that I got from my design into the software called epanet. That's exactly what I've been trying to emphasize to both old and upcoming engineers, that there's no software that does design. What software do is to help you to model and to simulate. Even AutoCAD is for modeling. AutoCAD does not do any design. It basically models your system for you. Yes, I can say this with every element of authority, that you, the engineer, are the one that will do the design, do the pipe sizing, and then carry those values into the software for the software to model it. Okay. So what we have to do now is to try your hands on this. So if I go to node 6 now, right, you see it's empty. Our elevation is whatever, based on what the surveyor gave me. Let's say 262 or 263. The base demand, if you remember yesterday, we got 0.28 plus the one for 6. Here was the water demand for here plus the water demand for here. So node 6 was 0.58 plus 0.23 or so, and we got 1.15 or so. All the things that we got last week, that's what we'll be doing. Any question? So once you input any value, you try and press enter for it to accept it. Enter, it will accept it. So I will impute all the values I got for the nodes and for the links. I will impute them inside these nodes. When I'm done, I will move to the pipes. So pipe section 6 to 13. 6 to 13, if you remember what it is. Okay, this is pipe section 6 to 13. The length is 210. The elevation is 252, we've done that. So 210, and the length is somewhere here. The length is here, sorry. The diameter is the diameter we got from our nomogram, right? Let's say we got a diameter. Let's say the diameter should be 50 mm. That's what we got that day. Because the discharge or the water demand, depending on how you want to call it, is about 0.58, which is less than 1. So when we read it from our chart, I think we got 50 mm pipe. So what will I do? I will now come over to this, my epanet model, and impute it. So I'll now come here. I will now impute it here. So if I click on this pipe, I'll come here. This length was because my auto length was on. I will remove this length and put 210. This is the auto length that captured, that the thing it captured automatically. This 75 is because I set it as 75. I'll show you why I did it that way. There's a place you can set your default parameters. Then roughness. This is roughness coefficient, 140. You can also set all this, but I'll show you how I set all this now in a few minutes. So how I set this is that as soon as I start my software, okay, it's blocking it again. As soon as I start my software, I'll go to project, I'll go to default. What you follow me? When I go to default, I will go to default. When I go to default, I will come here and I'll say, let every junction be J. Let my pipes be P. Some of these things you are seeing here is because I've been using epanet to do redesign. So I've set them how I want my annotation to be. After that, I go to property. I will set the default. All these things I say default parameter, 75 mm. Pipe roughness, 140. I'll go to hydraulics. Under head loss formulas, there are 3 of them. Hesse-Williams, Dashi-Weisbach, and Chesi-Manning. I use Hesse-Williams. Now, if you go to Google, for instance, this is Google. You say, what is the roughness coefficient for PVC? So it has already come out for me. What is the roughness coefficient for PVC? It will give you, you can see the value here. He says it's about 150, but me, I use 140. And that brings me to one other thing that I'm an advocate of to our engineers. Google is your best teacher when you are doing design. If you have not learned to use Google to look for information while doing design, all you need to do is to justify your parameters. If you choose anything as a factor, you choose your parameter. Okay, let me give you an instance now. I can come here now and say, what is drinking water standard for Germany? Water demand requirements in Germany, for instance. Many answers will pop up. All I need to do is to take my time and read it. It will give me the determinant of registered water demand in Germany. If I open it now, it will tell me the value. You see, it will give me 100 or 120, right? You can search for the one for the developing country, and so on and so forth. It's just there. So Google is so important. Okay, look at it here. German global water consumption, right? Let me see what it's telling me. Look at it. It's a 120 and 123 liters per person per day. What are you not telling me? If I want to do a design, you make comparisons. If you're looking for anything that you do. So now I'm looking for head loss formula for a PVC pipe based on Hesse-Williams formula. And I can go to Google and Google will tell me what it is. And I'll use it in my report. And of course, I'll justify it, right? Okay. Any question, please? Any question, please?
Sorry, can you mention the other names? You said Hesse-Williams, but it's starting from
go to your epanet. That's Weisbach, Hesse-Williams, and Chesi-Manning. If you remember our university days, we all came across them. You have it now?
Yes.
So if you go to your epanet, you go to projects, then defaults. Every software that you use have what we call default parameters. It means if you fail to put the right parameters, it will assume that parameter. It's always in every software. Right? It's always in every software. Once you do that, you can impute those parameters. Any question now? Okay, Engineer Victor, what's the question?
Good evening, sir.
Yes.
Can you hear me, please?
Yes.
Okay. My question is, sorry, it's a bit digressing, but just to ask, this same principle using this software, can you apply it to like your normal storm pipe network design? Can you use this for that?
Yes, you can use it, but the challenge you're going to have is that this is for like subsurface pipes, right? So for your storm design, you can use trapezoidal, you can use open drains. So this one does not accommodate that. But next week or next 3 weeks, we're going to see the one for pipe. That one is called SWIM. It's called SWIM, Stormwater Management Model. We download it still from EPA. SWIM, SWMM. SWIM.
Okay, thank you.
Stormwater Management Model, yeah, from EPA. You download that one too. That one will now give you a more diverse options. So you can choose the type of member that you are designing for. But this one is limited to closed pipe. Okay. Any other question? Please, Friday will come for Jonas Agbo and the other engineer. After the class, you call me and chat with me, please. Very, very important. Engineer Rindom Kuven. Friday, M. Ukafo. And Agbo, Jonas Chidebere. Thank you. Okay, we're moving on. Now, for today's class, before the end of this class, the last 30 minutes of this class, I'm going to share 2 videos to us where we're going to learn everything I've taught you today in a more relaxed, in a more calm way. As soon as this video is downloaded, I will also show it to us, send it to us. But I'm going to give you a video because I would like us to end by the next 30 minutes. This is weekend. But instead of us spending the next 1 hour, just like I did last time, I'm going to give you a 1 or 2 hours video that you play. I need to teach you how to use the software, number one. To teach you how to import things from AutoCAD. Because if I say let's open AutoCAD now, most of you don't have your AutoCAD. So at your time, you open it, and I think within the week, I'll be on our toes to make sure and simulation. So these are the parameters based on this tutorial, which is exercise 1, epanet exercise 1. The pipe parameters are here, and the node parameters are here, and the pipe parameters are here. So it has been the design has been done. The engineer have done the design. So our job is to model it in epanet. So look at this now. Open your screen, have this on while I now model it on epanet. So here is epanet software. If you open epanet, the first thing you need to do is to go to project, go to your defaults, and you set the parameters for the defaults. Here, what is the unit are you using? Are you doing liter per seconds, liters per minute, milliliter per day, cubic meter per hour, cubic meter per day? Or there are many of them, depending on where, cubic feet per second, and so on and so on. So we'll choose liters per seconds. What head loss formula do we want to use? I'll choose Hezin-Williams. There's all the other ones. What is the specific gravity of the fluid I'm designing for? It is water, it is 1. What is the relative viscosity? It is 1. What is the number of iterations I want the software to perform? Just leave it at 40, which is the default. What is the level of accuracy? Let it be to the 1 decimal place. If it's unbalanced, continue. So you can put in all these things, but the ones you don't know what it is, just leave it. You go to properties. What do you want the default for your node elevation? I'll say 0. So that means every node elevation will be 0 until I put the value I want. Tank height, you put default pipe diameter. I can put 50, I can put 75. So when I put 75, and you know I'm drawing a liter per second, what I'm telling the software is that if I forgot to impute anything, please assume 75 mm. That's what it means. I'm telling you to assume 25 mm if nothing was imputed. I'll go to level ID. Level ID is where I will put how I want my pipe to be annotated, what name I want them to answer. and so on and so forth, right? So that is that. So now I will come here. The first thing I saw in that place is reservoir. I'll put in my reservoir here. I now saw a node here. I put another node here. I put another node here. I put another node here. Now, they don't have numbers. If you look here, those nodes in those PDF, they have numbers, but mine is not having numbers. So I'll go to view. I'll go to options. Those of you that use AutoCAD, you know that every software have this option thing where you go and set some default parameters. It's always there. So I'll go to node, I'll say options. When I get to the options, I will ask him under notation, I'll ask him to display some things for me. That's just what it means. And I can increase the level to 2, right? I increase the node to say 6. I'll say, okay. Carry names. Can somebody try this, please?
Across the road.
Hello? Any question? Okay, so let me just continue. Now I'll place another node here. I'll place here. And I'll drop it. I'll go and pick a tank, and I'll drop it in. So Paul, can you mute yourself, please? Can you mute yourself? All right. So now I'll drop it. I'll now go and click on this node. I'll click here. I'll click here. I'll connect them with pipes. This is one of the challenges I have when it comes to this online thing, because some of us might be jittery, but believe me, this is not difficult. And the good news, if you go online, you see a lot of young Pakistanis and Indians who have used this software to do design. You learn from them. In addition to the one I'm teaching you, you learn a lot. So it's an open source software. Everybody's using it, and it's quite popular. You can see I have drawn it. So if I want to do that curvature that you saw there, I use a vertex. So if I come here, I click on vertex, I'll click on it. I'll say add vertex. I'll click on it again. I'll say add vertex. One vertex will appear. If you do it the first time, you don't see anything, but if you do it again and again, they will appear. So I think three vertices is enough for me to draw a curve. So what I'll do, I'll click here, drag. This is dragging. You click, turns to black, and you drag. You click, it turns to black, you drag. So if that is not enough for me, I'll add more vertices. Maybe let me add 2 more so that I can draw a perfect curve. Good. Are you saying something? Okay. Okay. So you can see I've modeled it. The next thing I will do is I will now come to those tables. Here you can see at node 1, the demand is 0. The elevation is 700.
How you
So
doing?
I'll go to node 1.
All right, you help me. You will free help me. As in the new trouser. I want.
So I'll go to here. I'll put 900 and the base demand. The base demand there is what? 0. Enter. I'll click on the next one. The elevation is 710. And the base demand is 150. But I made a mistake anyway, but I'll correct it. That mistake is that they are doing it not in liter per second. So I'll come here. I'll change my default. My default is no longer liter per second, rather gallons per minute. It's American design. GPM. And if auto length is on, it means everything is being drawn to scale. So for instance, if you click on this pipe now, it's giving you one length that you don't know. So it means later I'll have to click on it and impute the right length because auto length is on. If I want it to turn off, I'll go to project, I'll go to default, I'll go to properties, and I'll say auto length off. So every length will be based on what I'm going to impute it for now. So this is how you're going to do now for all these remaining parameters. Node 3, you put it. Node 4, you put it, right? Then if you finish it, you now go to the pipe parameters. Pipe 1, the length is 3,000. The diameter is 4 inches. So I go to pipe 1. This is pipe 1. Okay, the pipe name is not showing. So I'll go to view. I'll go to options. I'll go to annotation. I'll say display. Now it is giving me pipe 1, pipe this. I'll come here. Pipe 1, the length is 3,000 feet because American units, and the diameter is 14 inches. Enter. Pipe 2 is 5,000 feet. Diameter is 12. Based on these properties here. So that's how I'm going to impute all of them gradually until I finish my design. Right? So now I'm going to give us a video like this that will teach you what I'm supposed to teach you now in the next 2-3 hours. 1 hour, we have like 30 minutes to go, but 1 hour will not be enough even. So all I need to do now . So I'll go to my playlists.